Okay, so welcome back everyone. This is our part 2 for module 1, week 1, which is computer systems overview. In the previous lecture, we have discussed the hardware, storage, input, output, and we stopped on the operating system. Now, software applications, like we talked earlier, are different, but we are going to talk and concentrate mainly on user program applications. So to do that, first of all, what is programming? What do you mean by programming? So programming, or a computer program, is a sequence of statements that instructs the computer how to solve a certain problem. What do you mean by sequence? Sequence means instructions, lines after lines, sometimes thousands, sometimes millions of lines, telling a computer what to do. Programming is the act of designing and maintaining this program. How do you write the program? And programmers are the geeks, nerds who do all of this together. So a computer only understands machine language. What's machine language? Zeros and ones. This is the only thing that a machine understands. So it's a sequence of zeros and ones. So this is the machine code. This is a machine code. This is how it looks like. I bet no one will understand what's this, okay, including me. So a machine language, ML, statements stored in a computer memory. The computer memory is a sequence of switches on and off, so we just store the information. Now, talking about switches, you go and buy a new phone from Apple or from Samsung, they will tell you we are using the 7 or 5 nanometer architecture. This means each transistor is taking 7, which is 7 multiplied by 10 to the power minus 9 meters, the size of the switch. The size of the switch, which holds either a 0 or a 1. 10 to the power minus 9 is put like this: 3, 3, 3, 7. This is your 10 to the power minus 9. Bits and bytes. 1 byte is 1 bit, sorry, this is 1 bit. 1 bit is 1, and it will be 2 to the power 0. 1 kilobyte is 2 to the power 10. 2 to the power 20 is mega, giga, tera, peta. So nowadays you can go to the market and buy a laptop with 1 TB. But do we need a 1000 TB, which is 1 PB, 1 petabyte? Yes. Some companies, they need high storage and they go up to 1 petabyte of storage. You can easily buy a hard drive with 16 terabytes nowadays. You can find it easily. So things are becoming more and more bigger. If we talked about this maybe 10 years before, Giga was the ultimate dream for all of us. So computer programming, as you can see here, we are talking about machine language. But how can I program this way? Can we program in machine language? Imagine inputting input zeros and ones. Well, they used to do that. It was easy to make mistakes. It was hard to find the mistakes, and it was not portable, meaning if you do it in computer X, it will not run on computer Y. So this made programming very difficult. So on the other hand, we started using assembly, which is like small letters or small words: add, move, compare. So these are small mnemonics which assemble the instructions. Who will change this to this? We have this guy over here, which is our assembler. Now, The normal code, which is this is C++ code, will go through a compiler, and the compiler will generate the machine language, and sometimes will generate the ASM file, which is the assembly language. So for assembly, we used an assembler. For C, we use the compiler over here. So once more, we have the languages. We have the low level language, which is machine language, hard to read and not portable, compared to medium level assembly language, mnemonics, and it was easier to read and still not portable. So it's quite simple. You have small words, and these words, they were made things easier to read, but still, if you write an assembly language on an 8086, it will not run on any other device other than an Intel. On the other hand, we have the high-level programming languages such as C++, such as Java, such as Python, such as C#, such as, for engineers, we are going to use MATLAB, such as VHDL. All of these are programming languages. Okay, all of these are programming languages. These are all new languages which are portable and easy to read. Putting it all together, summing the whole thing, we have our application. After we load our operating system, the application will run from the hard drive into the RAM, and it will start running from the RAM on and forward and backward to the CPU. So we have fetch, execute, and store. This is called the machine cycle. We have for first fetch, then we have execute, and finally we have store. Fetch what, execute what, and store what. Fetch the instruction, execute the instruction, store the result. Fetch the instruction from where? Fetch the instruction from the memory. Get the instruction from the memory. Execute the result inside the CPU and store back the result into the memory once more. Engineering programs, or they use it for computers. We use it for data acquisition, which is obtaining and reading sensors. Device control, we use it for communication. Gaming, engineers, do we use it for gaming? Yes, maybe. Expert systems, process control, data analysis, computations, simulations, record keeping, automations, graphics, and finally our mechanical friends use it for robotics. So don't have the eraser. Okay, so sorry. So general types of programs. The general programming languages are BASIC, Pascal, COBOL, Fortran, C++. We are going to learn C++. Special programming include the MathCAD. Sorry for this. Okay. Special programming include the MathCAD, MATLAB, Mathematica, AutoCAD, SolidWorks. Applications: Excel, Word, Internet Explorer, PowerPoint, and our friend LabVIEW. So How do we write a program? This is a full idea of how do we write the programs. So to start writing a program, first you need to create a flowchart. So what's a flowchart? It's like the design of how am I going to solve a problem. A flowchart will consist of symbols. So we have the oval, which is the beginning and the end. Directed lines. We have the parallelogram, which denotes the operation. It's used for operations. We have the process, which is a rectangle. And we have the diamond, which is used for decision making, selection. So problem example solving. Let's say I want to fill a bottle with stones. I have a bottle. Hopefully I can draw one. Okay. We have a bottle and we want to fill it with stones. We want to fill it with stones. How do we fill this bottle with stones? So this is our question. It looks simple, but look at the assumptions. افتراضات. The assumptions are the bottle is present, the stones are present. So we have a bottle and we have stones. There are enough stones to fill the bottle. Bottle is empty, and mostly the stones can fit inside the bottle. So my bottle should be starting with an empty bottle, and then I should have some stones beside it, and some stones will fit, the others will not fit. I need to take them in here. So the algorithm: set the bottle up straight. Make sure that the bottle is sitting up straight. Check if the bottle is full. Is the bottle full? If yes, go to step 6. That means we are done. If not, go to the next step. Pick up a stone, try to put it in the bottle. If the stone is too large to fit, yani the stone does not go in, discard the stone. ارميه. If it fits, go to step number 3. Sorry. It doesn't fit, go to step number 3, pick another stone and try to fit it in. If it fits, go to step number 2, check. So here in step number 2, we check. Here, is the bottle full? This is our main question, which is here, which is step number 2. Is the bottle full? Yes, go to step number 6, which is stop. If no, pick up a stone. Is the stone fitting in? If yes, put it in the bottle and go and check. Is the bottle full or not? If no, discard it and go on. See, there is one starting point and one ending point for a flow chart. Another simple example is how to bake cake algorithm. Quite simple, but most of the time it gets burns with me. So heat the oven, gather the ingredients, then mix the ingredients, pour the mixture into a pan, bake the oven for 50 minutes, repeat the bake for 5 minutes until the cake springs back when you touch it. Yani when you touch the cake, it's like a spring. If it doesn't spring, every 5 minutes, keep checking on the cake. Then cut and serve for everyone. So this is the contents for week number 1. Hope it was clear. We are going to have discussions to discuss what we studied here in week number 1. Please go to the section for the lab and start installing the div C++ compiler, which I gave you the link for. It's an open source program. Hope to see you all soon. Thank you and see you soon.